today I will be talking to you about advanced oil and gas exploration and recovery. So I ended up being more interested in this topic than I actually thought I would be. Going more into depth and just kind of learning more about this industry and things that have happened in the past and kind of where they're heading now really caught my attention. Today I will be going more into depth about the background of the Deepwater Horizon and a little bit more about some negative effects that the oil industry has had on a number of things. Then I will be going into the process of gas and oil drilling. Then I will talk about the economic factors, the government regulations, technological advancements, and also what is next for the industry. So in 2010, April of 2010, one of the largest marine catastrophes had occurred. Millions of gallons spilled into the ocean after the Deepwater Horizon oil drilling platform exploded. So while they were traveling around the Gulf of Mexico, Deepwater Horizon resulted by a series of failures. This happened for a number of things. It can't just be said that one thing or the other. It was just a number of things built that just did not work out. One of the biggest issues was the little oversight in operation. Typically, oil rigs are equipped with blowout preventers, and also they're equipped with machines and multiple hydraulic valves that are designed to seal the well in case of anything that happens. Well, crew members of the Horizon couldn't activate these blowout preventers. So along with that, they were also missing a safety feature, which was an acoustic switch. An acoustic switch is kind of the backup to the preventers, the blowout preventers. So they didn't have working blowout preventers and didn't have a backup, which is an acoustic switch. This is something that the United States does not mandate. There are other countries that do require that these be a part of oil rigs, and some of the countries that do are Brazil, and I think the other one is Norway. Yes, Brazil and Norway are two countries that do. Not only are they required to have a blowout preventer, but they're also required to have an acoustic. Essentially what had happened was two of those things were not working. Well, they didn't have an acoustic, but they didn't have their blowout preventer working and doing what it was supposed to do. So after reaching pressures of 1,500 meters, there had been an explosion. Unfortunately, took 11 lives. This is one of the greatest spills and explosions that the United States has ever seen in our history. It was an eye-opening experience which kind of pushed regulators to make sure that their oil platforms are set up to where things like this wouldn't be possible, or it'd be very hard to even happen. So really what had happened was it wasn't a technology failure, but it was more of an overseeing failure because of a buildup that they just did not see coming. This was a tragic time for this industry, and they were hit hard because of the negative effects that had happened. But really, this, although it was tragic, was good because this had pushed them to look for other technologies, to look into laws that needed to be set in order to avoid this from happening ever again. Now that I have talked to you a little bit about the background of Deepwater Horizon and the negative effects it had on the industry, I will now go into the oil drilling process to better understand how things can go wrong and also how things can get better. So when drilling platform is in full operations, each section of the drilling stations are uninterruptedly updated through remote sensors. So there are constant updates through these sensors that are telling whether the pressures and the temperatures are matching up to where they need to be. There are many different sensors that give insight into the condition of the operation, and these include the pressure and temperature wellborns. So these sensors monitor how high either the pressure and temperature gets. If either of these numbers spike, that is how they know that adjustments need to be made in order to avoid catastrophe. Attaching a drilling string, which varies in size from 5 to about 50 inches. So after that, each of these sections is drilled and the steel pipe is dropped, and most times it is cemented in order to fill in the gap. In doing this isolates the high pressure areas of rocks that may come up from under the ground and avoid them from exploding. So after the drilling process, the hole is filled with mud. So what they refer to mud is a mixture of fluids, solids, and chemicals, and this greases the pipes and helps guide any broken rocks or pieces out of the way so that they can have a smooth flow of oil. So once the hole has been drilled, it must be completed or prepared for removal. So usually this involves puncturing the casing of the pipe and cement so that the oil and gas can enter. Sand or gravel is also often added to the bottom of most reservoirs to act as some sort of filter. So the most important phase of drilling from the perspective of a driller is the production phase. This is the period during which the oil and gas is actually pulled from the ground. For most wells, the pressure inside the reservoir is enough to push the oil and gas to the surface, but in more depleted areas, some other means like a pump stick or something that kind of could provide more pressure is used. A well reaches its economic limit, so that is when it runs out of enough product to cover the costs it's taking to get that product out of value, and when they're starting to lose money in operations, that is when they kind of cut the cord and call it the quits. So when this happens, the tubing is removed and the cement is poured to ensure that hydrocarbon reservoirs remain separate from water and cut off from the surface. Then the pump is removed, a cap is welded in place, and the whole thing is buried. A bit about the process of oil drilling. Now I will go into the economic factors of this process. It is important to understand the gas and oil drilling process, but it also is important to see the costs that go into this process, and also in research and development, and kind of just anything that is working towards advancing this industry. Investment in oil and gas exploration and production generates substantial economic gains, as well as increased energy independence. According to the Perryman Group, this industry as a whole generates an economic stimulus of almost $1 trillion in gross product each year, as well as more than 9.3 million permanent jobs across the nations. Some may argue that although it does bring in the money, it also costs a lot of money to keep up with. So it could actually take up to $10 billion in capital investment and many years to scale up to production of a basin. So including building the infrastructures to transporting and extracting oil or gas. This industry requires time and capital in order to produce, but again, this commodity is in high demand in nearly every country around the globe. So although it does cost and take a lot of time to produce, also gets its money's worth. About speaking briefly on the economic factors, I will now go into government regulation. The United States does not have as strict of regulations as other countries do. That was seen when we were speaking about the Deepwater Horizon. They weren't required to have a backup preventator, but they actually needed it at that time. So these states that do actively drill would have to also have tighter regulations. The current regulations are for on-site drilling and the chemicals used for the process of drilling. The local government's role to ensure that there will be sufficient structures and services to protect the environmental factors and also the safety of those who are on the drilling sites. Essentially, the health and the protection of the people is in the government's best interest. If the local government were not regulating these activities, there would be significant environmental issues to combat. So the government strategically plans out perfect areas, well, nothing's perfect, but areas that would best fit for oil drilling. That would be best for the community, that would be best for the safety, and that would be best for the environment. So they look at all these factors and they decide where would be best. The EPA, which is the Environmental Protection Agency, has granted state oil and gas commissions for oil drilling. Commissions are granted with the exception of Indian lands. So this is one thing that they have agreed upon with those on reservoirs, that they will not be drilling on their land. Which makes me think, I bet you they have the best oil. After speaking a little bit on government regulations in this industry, I will now go into the technological advancements, which is the exciting part. There are concerns that the oil and gas industry has tended to move a little slower towards new technologies because the high demand for these commodities has made it difficult to focus on anything else. So they're just working on pumping out product and they don't have enough time to really sit down and think like, what can we do different? How can we get better? And now engineers have decided to adjust things differently to where it would innovate a different product, or it would innovate the process in some sort of way. Actually, a company is starting to use finer grains of sand when experimenting with different ways of sealing off old pathways to allow new ones to be created for oil and natural gas to flow. Although this is a small adjustment, there are researching better ways of doing things. Another stride towards technological advancements is in software. So software is where it is at. Engineers have become reliant on software and sensors to kind of tell them where they need to adjust things. So these sensors tell engineers what areas within the well are lacking or what areas could be reduced in sand, water, and chemicals. So it is such a tedious little thing because you have to have the perfect amount of sand, perfect ratio of water, perfect ratio of this. So if one of them is off even by a little bit, it will cause some type of reaction. In following these sensors, they are able to increase oil production within a well. So as oil and gas companies advance their digital strategies, IT must also change. So right now, it is predicted that by 2025, 70% of internal IT roles in the oil and gas companies will provide or support new digital business services. So there has also been a shift in technology and roles within this industry, where technology is headed in the oil industry. It appears that it will soon be between machines and employees. So it will get to the point that workers will be more of monitors of smart machines, rather than to be a part of production physically. What is next for this industry? The upcoming technologies include systematic imaging, which will have important influences on how fossil fuels are developed. The industry has an imbalance when it comes to supply and demand, so this is why they're looking into other technologies so that this will not be an issue no longer. Technology has been what the industry has had to turn to in order to balance out the supply and demand. BP has pointed out that proved oil reserves are twice the level as they were in the 1980s thanks to better systematic imaging to pinpoint reservoirs, especially in deep water and below thick salt formations, among other technologies. Companies will start to see that they can achieve efficiency and productivity in costs and production. So for those who are worried about environmental factors, the good news is that these innovations will also include more environmentally safe options in the oil industry. An example of this would be the use of natural gases compared to the conventional diesel. This change has reduced the negative effects on air quality, and this is just one example of the many technologies that we are looking at in our future. There are many new technologies which have started to better serve the industry and also those concerned with the effects on the environment and the safety of those who are involved. So today I touched on the background of the Deepwater Horizon spill and the negative effects that comes with the mistakes within the industry. I then went into detail about the oil and drilling process, economic factors, government regulations, technological advancement, and what is next for this industry. I hope you all learned something new about advanced oil and gas exploration and recovery. Thank you, and hope you all have a great rest of your day.